For a closer look at the operation of the compressor, a reciprocating gas compressor will be presented in more detail. The major components are the frame and cylinders connected by the crossheads. The primary parts within the frame, cylinders, and crossheads of the reciprocating gas compressor are the frame that houses the crankshaft and includes the crankshaft bearings, the crankshaft that rides in the main bearings and is driven by the engine or motor, one or more crankshaft pins, and typically there are an even number to maintain balance, are positioned along the crankshaft. The number of these points along the crankshaft where connecting rods are attached determines the number of throws for a given compressor. Connecting rods that attach to the crankshaft pins and serve to transfer the rotary energy from the crankshaft to reciprocating linear energy in each throw of the compressor. The crosshead that rides in the crosshead guides and links the connecting rod with the piston rod. With each rotation of the crankshaft, the crosshead goes through one complete linear cycle from inner dead center to outer dead center and back to inner dead center. The piston rod that threads into the crosshead is secured by the crosshead nut or balance nut and goes through one complete cycle as the crankshaft rotates one revolution. The piston rod extends into the cylinder through a special sealing device called the packing. The packing is a series of rings that encircle the piston rod and provide a seal between the crosshead guide and the cylinder, as the piston rod reciprocates back and forth with each cycle. Several types of rings and ring materials are used to provide an optimum seal depending upon the pressures and types of gases and the position of the ring within the packing. The piston that attaches to the end of the piston rod and fits into the cylinder. Piston rings, wear bands, and rider rings, which are located in grooves on the circumference of the piston, perform several important functions. Depending upon the application, a piston will have some combination of piston rings, a wear band, and rider rings. The piston rings provide sealing that prevents gas from bypassing the piston. Wear bands do not seal the gas, but do provide a non-metallic wear surface. Rider rings combine the functions of a piston ring and a wear band. Rider rings are typically used on pistons that do not have sufficient length for a wear band and in applications that require a non-metallic wear surface. The cylinder in which the gas is compressed. The inside diameter is precision machined, and the cylinder is ion nitrided for hardness and wear resistance. Cylinder design is highly evolved to accomplish the high efficiencies, high reliability, and high level of safety required of Ariel compressors. Some compressors are outfitted with unloaders or variable volume pockets that are used to adjust cylinder capacity for flexibility of operation as operating conditions change. Suction and discharge valves that control the flow of gas into and out of the cylinder with each revolution of the crankshaft, and therefore with each cycle of the piston. Valve design is critical to assure optimum performance while providing excellent reliability under harsh and varying operating conditions. For example, each valve opens and closes up to 1,800 times per minute. The internal components must withstand twisting, vibration, shock, and the impact of continuous opening and closing. Also, the valve is exposed to wide temperature ranges and must operate in the presence of dirt, moisture, corrosive substances, and varying properties in the gas. Valves are very application sensitive, and the valves may need to be tuned or modified in a given compressor when the application or operating conditions change. For each cycle of the piston, starting from outer dead center, the suction valve opens to allow gas to flow into the cylinder as the piston moves to inner dead center. As the piston moves towards outer dead center, the gas is compressed, then is discharged at a higher pressure when the discharge valve opens. 2 lubrication systems that perform several important functions in the operation of the compressor. Along with reducing friction and reducing wear, the lubricants provide cooling, prevent corrosion, provide sealing, and dampen shock. One system assures that adequate lubrication is delivered to the frame components, including the crankshaft bearing and the crosshead. The second system is a force feed system that delivers high-pressure lubrication to the cylinders and the packing. A distribution block allocates the flow of lubricant to each point of delivery in the force feed system. A protective device continuously monitors the flow of lubricant and provides an alarm and/or system shutdown if lubricant flow is interrupted.